Yes, welcome to another class today. And today we will be running through the last topic under the first aspect of the GRE quantitative reasoning, that is arithmetic. Now we are wrapping up on the aspects today. Okay, so now, and the topic we are looking at today, which is the last topic under arithmetics, is percent. We're talking about percent, or what you call percentage. All right, so I want to believe you have already gone through the previous topics and you have understood everything in those topics. So without wasting any time, let's move on to what we have for today's class. All right, now what are we going to be discussing under percent? We'll be looking at percent. We'll be talking about mathematical interpretation of percent statements. Okay, and we'll be talking about percent change, and we'll also discuss profit and loss. All right, so we'll run through these 4 subtopics in this class today. And without any further ado, let's get into business. Okay, now when we talk about percent, what do you mean by percent? The 10% means per 100 or out of 100. Percent means per 100 or out of 100. Out of 100. So when you're saying you are finding percent of something, it simply means that you are dividing that thing into 100 places and you are taking a part of it. You're taking a part of it. Okay, so for instance, if you are finding 30% of something, that is, divide that thing into 100 places and take 30 out of the 100. Take 30 out of the 100. That's one by 30% of something. So for example, if you are finding, let's say, 30% of 500. Okay, you want to find 30% of 500. What it simply means is that you want to divide 500 into 100 equal parts. That is, divide 500 by 100, and that gives you 5. So you now want to take 30. That means you have 5 in 100 places. 5 in 100 places. So you now want to take 30 out of these 100 5s. So which means you are taking 30 of 5, which gives you 150, and that is 30% of 500. All right, and that's why you can just say 0 eliminate 0, 0 eliminate 0. So 30 times 5, then you have 150. So that is 30% of 500. So that's what my percent. Dividing something to 100 places and taking a part of it. All right, now 30% simply means 30 out of 100. All right, like I explained, 30 out of 100. Divide it to 100 and take 30 out of it. So that's 30 over 100. So that's how you write it. You write it in the fraction 30 over 100, and when you simplify, you have 3 over 10, and which is still the same as 0.3 in decimals. Okay, 150%. Now 150% is same as 150 over 100, which is also 3 over 2 when you simplify that fraction. Then same as 1.5 in decimals. Okay, 1.2% same as 1.2 over 100, and that is also equal to 0.012. Remember how you do it? We treated that under decimal. That is, move your points to the left. Since you are divided by 100, you have 2 zeros. Move your point to the left 2 times, so 1, 2. And you're going to have 0.012 as the decimal form. 300%, that is 300 divided by 100, which means 3. All right, which means 3. So that is taking 3 times of the whole quantity. All right, so that's how we express our percent in fractions or decimals. All right, you can even have it in ratio. 3 over 10 is same as 3 ratio 10. 3 over 2 is same as 3 ratio 2. So 3 ratio 2 is same as 150%. We've talked about that in ratio as well. You can check the video. So note, 0.01 is not the same as 0.01%. All right, so this is 0.01. Why this one is 0.01 over 100? All right, so they are not equal. So when you see percent with it, then it's becoming something different. So 0.01 and then 0.01%, they are not equal. So this is 0.01 over 100, which will give you 0.0001. All right, That is, when you divide 0.01 by 100. Remember when we did decimal? So like I said, this point, since you have 2 zeros here, so it means you move this point to the left 2 times. So 1, 2. So your point is now here. So I put 0 here and 0 here. So this means this will give you 0.0001. Alright, so that is our 0.01%. 0.0001. So it's not the same as 0.01. So just note that, right? Okay. Now we have mathematical interpretation of percent statement. Mathematical interpretation of percent statement. Now, 90% of questions you see on percent in GRE, they will definitely be in words. They will express the question in words. So you're expected to be able to express those words in mathematics, like mathematically. Express them in terms of expressions or equations. And you need to understand how to do that in order to be able to answer percent questions easily. So when you see it in words, how can you write it mathematically? So that's what we are trying to look at here. So first, if you say something like that, says what is X percent of Y? What is X percent of Y? As you know that X percent means X over 100, just like what we did previously. X percent means X over 100. So of means times in mathematics. Of means times and then Y. So you have X over 100 times Y. So just a simple multiplication of fractions that you need to do there to get the answer. So for example, if you have what is 40% of 150? What is 40% of 150? That is 40 over 100 times 150. Alright, 40 over 100 times 150. So when you do that, 0 here can only 0 here, and 0 here can only 0 here. So you have 4 times 15, which will give you 60 as the 40% of 150. Okay, now another one is what percent of X is Y? Or Y is what percent of X? Okay, can you get that? What percent of X is Y? Or how many percent of X is Y? Or you can say Y is what percent of X? So this mathematically means you're looking at Y as a percent of X. So that will be Y over X, not X over Y. Or not X over 100. You're not doing X percent. You're saying what percent of X is Y? So that's Y over X times 100. Y over X times 100. So that is how you can express that mathematically. Now, if this is not too straightforward for you, another way you can interpret this statement is this. You can just interpret it directly the way the statement is written. Okay, what I mean by that is this. I can simply express this statement like this directly. So what percent of X is Y? Okay, so what percent of means times X is equal to Y. So this means this over 100 times X is equal to Y. Alright, so if I need to make this subject, what will it be? This will be this X over 100 is Y. Or I can say this X is equal to Y times 100. And I can do what? Bring X multiplied by X. So it gives me this will be Y over X times 100. So that's why you have it there like to be Y over X times 100. But you can interpret it directly. So what percent of X is Y? Okay, and you still get the same answer. Alright, so that is how we interpret that kind of statement mathematically. So, example, it says, how many percent of 150 is 40? How many percent of 150 is 40? Or what percent of 150 is 40? So, that means 40 over 150 times 100. So 40 out of 150 is how many percent? That's what I'm simply saying. Alright, so what percent of 150 will 40 be? So that's 40 over 150 times 100. And when you simplify that, you get 26.7%. 26%. That means 26.7% of 150 is what will give you 40. So if you find 26.7% of 150, you will get 40. That's exactly what this statement is saying. Okay. So another one says X is what percent less than Y. Alright, this one, what percent change, you will still look at later. X is what percent less than Y. So X is less than Y. So you can just take a positive difference. First is to know the difference between X and Y. Okay, so it depends on the way you want to do it. If you want to take a positive difference, fine. If you want to take a negative difference, fine. You will still get the same answer, just like your answer could either be positive or negative. And that just tells you what is happening. And they change. Okay, so X is what percent less than Y. So take the difference. Alright, the difference will be Y minus X, since X is less than Y, and I want a positive difference. That means Y minus X than Y. So this Y is what will be your denominator. Where some students have issues with this kind of statement is they will be confused which one should be my denominator. Is it the Y or the X? The denominator is not a problem. The denominator is just the difference. So get the difference, no problem. But the denominator. Now, let me just use this word for you to just note it anytime. Anything that you see after this than, when you see less than, anything that follows that than is what will be your denominator. Just note it that way. Maybe that will make you understand it easily. So less than this. So that's what will be the denominator. Less than this. So we are taking the change with respect to this Y. That's what we are doing. So Y minus X over Y times 100 is going to be what? What will be the answer in percent? So we're able to know by what percent is X less than Y. That's by what percent of Y is X less than Y. That's what we are trying to say there. So for example, if you are finding how many percent less than 50 is 30. How many percent less than 50 is 30. Now you can see I've structured the question in a different way. Here I told you anything you see after less than is what will be your denominator. Now they can also rephrase it like this just to confuse you a bit, but it's still the same thing. How many percent less than 50 is 30? So it's still what you see after that than that you put as your denominator. So the difference will be 50 minus 30, which is what we have here, divided by what you see after the word than. That's 50 times 100. That gives you 20 over 50 times 100, and that gives you 40%. So that means 30 is 40% less than 50. It means you find 40% of 50 and remove it from 50 before you can get 30. That's what that is saying. So just how you can, that's the meaning of it, that's the interpretation of this. Okay, so answer will be 40%. Same way with greater than. Y is greater than X by how many percent? Y is greater than X by how many percent? So same thing, find the change or the difference between them. Alright, divided by what follows your than. Alright, the X times 100. So you can say an example here. By what percent is 50 more than 30? By what percent is 50 more than 30? So 50 more than 30. The difference will be 50 minus 30, which will be this, all over than 30. 30 will be the denominator times 100. That will be 20 over 30 times 100, and that gives you 66.7%. Alright, so 50 is more than 30 by 66.7% of 30. That's what that means. Okay, so this is how we interpret our percent statement mathematically in order to be able to calculate easily. Alright, let's move on. Now we have percent change. Percent change. Now a percent change is change divided by the initial value times 100. That is when you look at change in percent. Alright, something increases or something decreases. So by what percent has it changed? By what percent has it changed? So where change is the final value minus the initial value. Alright, final value minus the initial value, or we call it original value. Initial value or original value, they mean the same thing. Okay, so our change could be an increase or a decrease. So if it's an increase, then we have what we call percent increase. Now percent increase will be the increase divided by the initial value times 100. While percent decrease will be the decrease divided by initial value or the original value times 100. All right. So your increase, of course, if you increase, that means you are going from lower to higher. All right. You're increasing something. So from lower value to a higher value. So that means the final value must be the higher one, while the initial value must be the lower one. So to get the increase, you have the final minus the initial. But if you are decreasing, that means you are going from a higher value to a lower value. Higher value to a lower value. So the change or the decrease to get the positive result will be the initial value minus the final. Okay, the initial value minus the final. All right, so that is one thing we have to understand here, because what the important thing is, you want to get a positive result. So if I'm decreasing from higher to lower, all right, the higher is the initial, the lower is the final. So that's how I have to do initial minus final to get a positive change, a positive answer. All right, and if I'm doing increase, that's from a lower to a higher. So the higher one will be the final and the lower will be the initial. So that's what so to get your increase, final value minus initial value, and to get the decrease, initial minus the final value. All right, so then that will be to get the percent change. They'll be able to divide by initial times 100. Now let's look at this simple example here. One says, if the price of a pen increased from $20 to $25, find the percent increase. The price of a pen increased from $20 to $25. Find the percent increase. Okay, now let's look at this example here, and let's see what we are going to have. Okay, let's see what we are going to have. Now, so the question says we are increasing from $20 to $25. So what is a percent increase? Okay, so as you know, our percent increase will be equal to the increase divided by the initial value, all right, times 100. So what is the increase? As you can see, the increase will be 25 minus 20. That's the final minus initial, divided by the initial, where the increase started from, all right, which is going to be 20 times 100. And this gives us what? 5 over 20 times 100. So 20 here, 1 here, 5. So what do we have? We have 25% increase in the price to have $25. So that means we increase this initial price by 25%. That's if you have 25% of 20, you get what? You will get $5. So $5 plus $20 will give us $25. So we increase it by 25% to get this $25. All right, now let's keep that there and let's go back to let's go and check the second example there. Now the second example says, if the price of a pen decreased from $25 to $20, find the percent decrease. Can you see that? Now the price decreased from $25 to $20. Find the percent decrease. Now let's see what this one will be. Now this one is saying we are decreasing from 25 to 20. So it's a decrease. So what is a percent decrease? Now let's check. Don't forget, our percent decrease will be the decrease divided by the initial value times 100. And our decrease will be what? The initial minus the final, all right? The final divided by what? The initial, where the decrease started from, and that is 25 times 100. And what does this give us? It gives us 5 over 25 times 100. So here 1, here 4. So 4 times 5, we have 20%. Now, one thing I want us to notice here is this. When you have an increase from 20 to 25, we have the same change, all right? We increase by $5, but the percent change is 25%. Now, a decrease from 25 to 20, we have the same change of $5, but the percent change is 20%. So that means the change must be equal, but that does not mean the percent change will be equal. No. Okay, so This equal change does not give equal percent change all the time. So you have to be careful with those kind of question. All right, it's kind of question. So it is very important you try to check what the percent change will be. The fact that you have equal change does not mean you are going to have the same percent change. So what I'm trying to say is, for instance, you see a question that says quantity A, the percent change in the price of a car that increased from $2,000 to $2,500, and quantity B may say the percent change in the price of a car that decreased from $2,500 to $2,000. Okay, so the question is talking about percent change, so don't be deceived with the issue of increase or decrease. Maybe you say the increase will be positive, decrease will be negative. No, that's not what the question is saying. We're talking about the percent change here. So we know the change could be increase or decrease. It's fine. That's just talking about the direction of the change. But the value of the change will always be positive. All right. So the change either increase or decrease to be positive something percent, some positive something percent. So now this one increased from 2,000 to 2,500. This one decreased from 2,500 to 2,000. Now that means you're going to have the same change. Definitely the change here is increase of $500. While the change here as well is a decrease of $500. So the same change. Forget about change, increase or decrease. The same change. $500, $500. But because it's not talking about change. Because it's talking about percent change. Percent change. So the percent change will not be the same. Automatically, just from the example we just did, they will not be the same. So the fact that the changes are the same doesn't mean the percent changes will be equal. So you have to check, calculate it before you can pick your right answer. So just get that right so that you won't be deceived. Okay? Alright, moving on. If a quantity X increases by 20%, then the new value of X is equal to 120% of X. And that's 120% of times X, which is 1.2X. So here, we are looking at a faster way to handle our percent change. Okay, handle our percent change. So if you have a percent increase given in your question, this one says this statement says the quantity increases by 20%. So the quantity X on its own is a whole, is a total, which is 100% on its own. So increasing it by 20% now turns it to 120%. That's what we are saying. Just to make it work faster instead of wasting your time. Alright. So 120% of X, that's 100% plus 20%. That's an increase. So it becomes 120% of X. 100% of X. And 120% of X means 120 over 100 times X, which will be 1.2X. So that's just to make our work faster so that you don't have to waste your time. You don't have to waste your time. Alright. So for instance, you may have something like, so maybe you increase $50 by 10%. So what will be the value? If you increase $50 by 10%, that means the final value, or maybe the new value, will be equal to what? 110% of 50 straight away. Alright, so that's, since you're increasing by 10%, that means 10% plus 100%, giving you 110%. So this eliminate this 5 times 11, we have $55. So this is $55. So we will not need to find 10% of 50 first and then add to 50. That will be a waste of time. So simply straightforward 110% of 50, and that will give us $55. That's what this statement is simply saying. Okay, so another one says if a quantity Y decreases by 15%, then the new value of Y is equal to 85% of Y. and that is equal to 85 over 100 times y, and that is 0.85y. Yeah. Okay, so this one is a decrease. Y is 100% on its own. So decreasing it by 15% means we are removing 15% from 100%. So giving us 85%. So all you need to do is subtract 15% from 100 if you are doing decrease. If you are doing increase, add it to 100%. If you are doing decrease, subtract from 100%. So 100% minus 15% will give us 85%. That means the new value will be 85% of y. That's 85 over 100 times y, which will be 0.85y. It's as simple as that. It's as simple as that to save your time. Okay? Now, if your quantity m first increases by 20% and then decreases by 20%, then the new value of m will be equal to, now look at here, we're having successive changes. In GRE, you can have this kind of question where the value of a car increases by 30% in 2018, then increase again by 20% in 2019, and then decrease by 50% in 2020. What is the final price of the car in 2020, or something like that? So when they are having that kind of question, it's very easy to do. All you need to do is look at what I've just put here. Quantity m increases by 20% first. So if it increases by 20%, the initial value is m, that's 100% on its own. Now, if it increases by 20%, then it becomes 120%. So that means 120% of m. And then decreases by 20%. So decreasing it by 20% means now you are going to have 100% minus 20%, giving us 80%. Okay, let me make it clearer so that you can understand what we are doing here. Okay, so the first statement, increased by 20%. What does that mean? That means we have 120% of m. Now, after that first increase, this is a new value of our m. And this new value is seen as a whole on its own, like this, as 100% now. That's a new value. Alright, so you don't see it as 120% anymore, you see it like 100% on its own. Now, the second value statement now says then decreases by 20%. So that means we remove 20% from 100%, giving us 80%. That means we're now having 80% of this new value. Can you get that? 80% of this new value. So now giving us something like this, then like this. So this is now the new value after these two changes. If we have another one that says maybe increases again by maybe 15%. What does that mean? That means we have 15% to 100% giving us 115%. So this is a new value now after these two changes, and it's now 100% on its own. Now, increasing it by 50% now means it will now become 115%. So we'll be having 120 over 100 times 80 over 100 times m, now times 115%. Okay, so which we can now put together as 120% times 80% times 115% times m. As you can see that all we are just doing is keep multiplying by by the change. Yes, that's what it will be turning to. Okay, so the first increase by 20%, 120%. The next one is decreased by 20%, which is 80%. The next one is increased by 15%, which is 115%. So if you have more, that's how you keep multiplying, So you just do your work straight away and you will not have to stress yourself. Okay, so that is exactly what we are saying in that point. So from here, m first increases by 20%, that means 120%, and then decreases by 20%, that is 80% of m. So giving us 120 over 100 times 80 over 100 times m, and 120 over 100 is 1.2, 80 over 100 is 0.8 times m, and when we multiply this we have 0.96 m. Now 0.96 m, if you turn it to percent, 0.96, what does it mean? It means 96 over 100. Alright, 0.96 is 96 over 100, and that is 96%. So that means at the end of the two changes that we have here, the final value of m is now 96% of m, meaning it is no more up to 100% anymore. Alright, from 100% of M now to 96% of M, or you can see from 1 M to 0.96 M, showing you that it has reduced finally at the end of the two changes. So you can see that increasing by 20% and then decreasing by 20% doesn't mean the M will go back to the original value. No, because we are changing different values. So that is why you increase by 20% and you now decrease by 20% back. It doesn't mean you go back to the original. No. So you have to check. Alright, so as you can see now, what we are having is 0.96 M. Yeah, that's what we have, 0.96 M, or 96% of M. So what does this statement imply? What it implies is that M has lost 4% of its value during these two changes. Okay, M has lost 4% of its value during the changes. Now it is now 96% instead of initial 100%. So it has lost 4%. So that 4% is the change in the value of M. Alright, that's the overall percent change. The overall percent change in M. So when they give us a question like this, they can ask us the final value and they can still ask us the overall percent change. Overall percent change. So as you can see here, hence 0.96 M implies there is an overall total of 4% decrease in the initial value of M. And you get that? Overall total of 4% decrease in the initial value of M. Okay, so that is one thing you have to understand when you are solving this kind of question. Let me just show you an example. Okay, now let's say this example. It says the price P of a car increased by 10% in 2015. The price then decreased by 20% in 2016 and later increased by 10% in 2017. Now quantity A, the percent change in the price of the car from 2015 to 2017, and B, 4%. 4%. So as you can see here, it is very clear, just like what I just explained. 2015, there was 10% increase. The initial price was P. Now 10% increase in 2015. So that means you're going to have what? 110%. Okay, 10% increase. Then decrease by 20% to 2016. So that means times 20% decrease. That will give us what? 80%. Times, now we have another 10% increase in 2017. Okay, so that will be what? 110% times P. Okay, so and what do we have here? You can decide to cancel out the decimal number, the zeros, or probably multiply in decimal, anyhow you want to do it. So maybe I cancel 0 here, you cancel 0 here, I cancel 0 here. Okay, so I will just have 11 times 8 times 11 divided by my 10 times 10 times 10, which is 1000. All right, or you can turn it to decimal numbers. So this will give you 1.1 times 0.8 times 1.1 times P. All right, so and when you multiply this out, what does it give you? All right, it gives you 0.968p. 0.968p. And like I said, if you have to turn this to percent, 0.968p, if you have to write as something over 100, what does that mean? That is simply 96.8 over 100. All right, like if you count 1, 2, moving your point 1, 2 to the right. Okay, that's 96.8 over 100 of P, or 96.8% of P. So what is this telling us? It means that now we are having our P reducing. Okay, as you can see here, it was 100% before, now 96.8%. And it has reduced by how many percent? You can simply just subtract to know the number of percent. Subtract 96.8 from 100. And what does that give you? That gives you 3.2%. So that means our P has reduced by 3.2%. So the percent change is 3.2%. And quantity B is saying 4%. So that means quantity B will be greater here. Alright? So it will be greater. So we have 3.2%. change in the original price of that car. Okay, so that's how we answer this kind of question in GRE, so you can note that. Okay, so I want to believe that is very clear now how you can answer this kind of questions. Okay, now moving on. 1.05x, what does it imply? It means 105% of x. So if you carry out your calculation and you get something like this, how you can express it in percent? Like I told you, you can just move the point to the front, 2 times 1, 2. Okay, and that turns to 105 over 100, and which means 105% of x. And when it's 105% of x, what does that mean? It simply means 5% increase in the initial value of x, as you can see. So because x on its own will be 100%, so if you have 105%, that means x has increased by 5%. That's increased by 5%. So the percent change in the value of x will be 5% increase. 5% increase. 1.3y. What does that mean? That means 130 over 100. That will be 130% of y. Alright, so that implies you have 30% increase in the initial value of y. 30% increase in the initial value of y. That is what this means. 30% increase initial value of y. Okay, so you have, because initial value will be 100%, now you have 130%, so that's 30% increase. 0.75 q, what does it mean? In percent, that is 75% of q. And 75% of q means that q has what? Has reduced. Because once you have anything less than 100%, that means that quantity has reduced. It has decreased. Alright? By how many percent? By what it remains to make it 100%. That's 20% here. So when it is more than 100%, that means that's increased by that extra on the 100. So 0.75q means it has reduced or decreased by 25%. So 25% decrease in the initial value. Now if you have something like this, x is equal to 0.7y. How can we interpret this in terms of percent? X is 0.7y. If I may ask you first, which one is bigger between x and y? It is clear x here is less than y, because this 0.7 is not 1. If it is 1, that means they are the same. But since it is less than 1, it means this x is smaller. Alright? X is less than y. And 0.7 in percent is the same thing as 70%. 70%. So this implies x is less than y, or y is greater than x. And this also implies that your x is 70% of y. So not up to 100% of y. So meaning they are not equal. Meaning x is not bigger than y. X is less than y. So x is just 70% of y. And that implies that x is less than y by 30%. Remember, to make up 100. So that means x is less than y by 30%. So that's how you can interpret all this kind of statement when you calculate your percent. How you interpret. So this statement is simply telling you x is less than y by 30%. Or x is 70% of y. Another one is x is equal to 1.1 y. X is equal to 1.1 y. And what does this imply? This means x is 110% of y. X is 110% of y. Yeah, 1.1 is 110%. So it means x is 110% of y. And if that is the case, what does it mean? It simply means x is bigger than y. Because x is more than 100% of y. It is 110%. It means it's equal to 110% of y. So meaning x is greater than y by 10%. That extra on the 100. That's x is greater than y by 10%. That means y is less. So you can calculate by 1% y is less as well. Alright. But here we can easily say that x is greater by 110%. So if you want to know by what percent y is less, that means you make y subject of this equation. Let's check that out. We are having x is equal to 1.1y. So like we said, it means x is greater than y by 10%. Right? By 10%. So because here x is 110% of y. So x is greater by 10%, the extra on the 100. Now, the question can ask you, y is less by how many percent? If x is equal to 1.1y, then by what percent is y less than x? We know that x is greater by 10% now, it's clear. But if we want to know by what percent is y less, so y is less than x by how many percent? Let me put it that way. By how many percent? If we want to know that, all we need to do is from this equation here, make y subject of the equation. Alright? Make y subject of the equation. Express y in terms of x. That's what we want to do. So from here, we know that x is, let me write it like this. I will write 1.1 as 110 over 100. Or I can say 11 over 10. Anyhow, still the same thing. So 1 here cross multiply. What does that mean? That means 11y is 10x, or that means y is 10x over 11. Okay, so I will express this in decimal. It means y will be 10 divided by 11. What will that give you? That gives us 0.909090 like that, x. So this simply means y will be 0.90. Let me write it like this, 9 of x. Okay, so in this kind of question, since the decimal is repeating decimal, they will simply put it like approximately. They want us to approximate, definitely. So now, as it is here, I can approximate to 0.91x. So that means my y is what? 91% of x. So what does that tell me? It means that y is less than x by what? What does it remain to make 100%? It's less by 9%. Okay, y is less by 9%. It's less than x by 9%. X greater than y by 10%. While y is less than x by 9%. Okay, so that is how we can find this and interpret this kind of statements in terms of percent change, and we see the relationship between x and y in terms of their percent. Okay, so this is where we'll be stopping for this class today. We will be completing this percent in the next class, definitely. We won't be able to run through everything in this class or in this video. All right, so I want to believe you have learned so much about percent. I want you to try and go through the video again, try to see some things you need to pick more and practice more. Then in the next class, we will try to finish it up and then look at some standard questions and see how you will be able to handle questions on percent in GRE. We have been able to look at some good questions, of course, like this one. If I structured it very well, it's a very good question, and so on like that. So we'll look at more in the next class and ensure you don't miss that, definitely. All right, see you then. Bye.